Good morning, everyone. I'm Vamsi, Practice Manager from AWS Professional Services. So I was so excited to be here yesterday, and I went through a lot of intense and heavy-duty sessions yesterday. So I thought maybe I'll start my session with a lighter question. How many of you know Shah Rukh Khan? Shah Rukh Khan? Awesome. That's great. So what a great personality, right? I mean, he's so accomplished, talented, and so spirited. Well, I'll ask the next trivia question. What is his recent blockbuster? Shah Rukh Khan's recent blockbuster movie? Awesome. It's Pathan. Thank you. The reason why I ask that is basically because we feel Amazon Aurora is our Shah Rukh Khan, and the serverless V2 is our serverless V2. How about that? Thank you. Basically, I wanted to also say, when you speak about such accomplished personalities, you don't try to introduce them. So you basically talk about why they are actually accomplished, what are their traits, and then what is the recent blockbuster. So that's the reason I thought I will do it the same way. I'll basically talk about why Amazon Aurora is so accomplished or why it has that stature. And we'll talk about the recent blockbuster, which is our serverless V2. Okay, so Amazon Aurora is a fully managed relational database, which is highly performant. It has enterprise class features, and it is no maintenance. So it's basically highly performant and highly scalable. Okay. So when I talk about highly performant, I also wanted to say that it's fully compatible with MySQL and also with PostgreSQL. So which basically means that you can migrate your Postgres databases and MySQL databases onto Amazon Aurora without impacting your applications or making any changes to your applications. So that means your applications can continue to operate even after migrating to the database. You don't need to make any changes to the code, or you don't need to make any changes to your database objects. And also by doing this, you can increase your performance. So when you migrate a MySQL database, you can actually accomplish 5x performance improvement. And when you migrate a Postgres database, you can accomplish a 3x performance improvement. So all this, despite actually migrations, you will also be able to see a 1/10 of the cost when you actually migrate to AWS Cloud. So that is something that I want to convey. And also the enterprise class features. 99.9% availability or durability is something that's given. And it is also multi-AZ, so that means you basically have 6 copies of redundancy in case of any disaster recovery or failover. So this is something that's readily available for you. And it is also a global database, so which means you can deploy your databases to more proximity to your users. Okay, and it's self-healing. That means it's instant crash recovery. So this is something that's available. And there's encryption at rest, and we also have an option of encryption in motion as well. Okay, so there are no servers to manage. So that basically means you are saving on your administrative costs. And there's built-in integration with many of the services that are available in AWS. So one of those, my favorite, is basically the integration with machine learning SageMaker. Okay, and the logging system is integrated to the CloudWatch. And also there's integration with the encryption processes as well. So this is something that I want to talk about Aurora. So there are more aspects that I wish to cover, but I'll hold upon to that. And just want to show you some of the metrics. So IDC Research has actually surveyed different organizations that have actually leveraged the best of Amazon Aurora, and they're able to see the benefits. So there are 6 customers that actually IDC has talked about, and these are the metrics from interactions with the 6 customers. So as you see, in essence, there's a 4.4 million average annual benefits per 100 Amazon Aurora databases. And the most favorite metric of mine here is basically 61% increase in the database managed by the DBAs. So that means the productivity of the DBAs is significantly higher when you basically migrate to Amazon Aurora. And I also wanted to show some of the important logos. So these are some of the customers that we are actually help them migrate their databases onto Amazon Aurora. You could see there's a wide range. So Expedia and Airbnb in travel and hospitality industry. And you can also see Capital One from financial sector, AstraZeneca in pharmaceutical, and then you can also see Electronic Arts in the gaming industry. So all I want to convey is it's not specific to one domain or one business, and this is also something that supports enterprises of different scales, right from startup to organizations that are completely matured as an enterprises. So Amazon Aurora is for every customer that wants to pursue relational database for their solution. And then I want to spend a few minutes talking about the core features of Aurora. We talked about 99.9% durability, which is a given. And then there is instant fine-grained serverless scaling. So what that basically means is that you could scale your Aurora instances at a smaller grain, that is 0.5 ACU. ACU is basically Aurora cluster units. So you can scale to the level of smaller grain of 0.5 ACUs. And then it's a global database, so if you want to take your database more closer to your users for better performance, better access, or even for that aspect of failover, so you could deploy your databases globally. So encryption is at rest and encryption in motion. So we have a key management process, and we also have SSL to basically do encryption in motion. And then automatic continuous backups and point-in-time recovery. So this is basically where we give an option for the database users to create a backup of their databases every 5 minutes. So that means you would be able to recover your databases point in time at a maximum of 5-minute loss. And the recovery is to the extent of the time that you actually take the backup. So there's multi-AZ deployment. So there are 6 database copies that are created for redundancy across 3 availability zones. And then it's obviously, of course, I mentioned, fully compatible with MySQL and PostgreSQL. So the scaling here, the significant aspect is the scaling can be happening at a push of a button, in the sense like you don't have to be aware of the event that there's a scaling happening on your database. Okay, so there are multiple reads, scaling options that you basically have, and also Aurora is decoupled from both compute and storage point. So that means if you're not using your database for any compute, you can hold it off and then just pay only for the storage. Okay. The other aspects are the integration with SageMaker. I just want to touch upon that particular point. So when a lot of innovation happens on machine learning or artificial intelligence, so SageMaker is a popular tool available to create models and train the models and run the models. So basically Amazon Aurora is very handy for the users. Basically they can use their SQL knowledge to provide or feed in data to the machine learning applications or machine learning models. So the CloudWatch metrics are available so that the logging information is already captured in your CloudWatch. So I can actually go on. So basically when I was in training, or when we try to train our consultants on the features of Amazon Aurora, we generally start about a few hours before the lunch and then go on till the sun sets and the cows come down. Cows come home. So, but my friend Hari here is making a valiant effort to explain all of that in next 12 minutes. So all the best, Hari.
Hey, hi. Good morning, all. Thanks, Vamsi, for the lovely analogy of Shah Rukh Khan. I, being a particularly big fan of Shah Rukh Khan, I love that. I hope the other fans of Shah Rukh Khan will also love it. Okay, so before really diving into the serverless part, actually, I just wanted to address what is the problem statement we are trying to address with serverless v2. So let's get to that core of the issue, and then let's dive into some of the serverless v2 features, actually. Now, most of you must have agreed, or rather I would say that this is a very common challenge most of the DBOs, or as an infrastructure guy you would face, is the capacity management, actually. Now, what do you mean by capacity management is you won't get any kind of a capacity at the right time or the right place, actually. That is you, at times you might be over provisioning it, at times you might be under provisioning it. So here is a bunch of metrics what we have gathered, okay, and it shows that we do have the two metrics, rather say that peak and average, actually. and across. And you see that the delta between the peak and average is huge, and that's what you are most of the times is going to be unutilized, and you are going to pay for that actually. And that's where we are sketching and saying that yes, serverless is going to come into picture with this. Now, when you try to under provision is, you always run into the risk of degradation performance actually. And of course, the flip side, of course, is if you're going to over provision it, you're going to spend a lot of money on that. Or else, if you do a middle ground and say, okay, no, I'll take a look at closely monitor my systems and try to tweak that on the fly, or you do all of that, it's going to be very cumbersome, it's going to be very tiresome, I would say, and it requires a lot of expertise, I would say, to really achieve that. So this is where we are trying to address the problem, and let's see that how it goes actually. Okay, so we introduced Aurora Serverless 2018, but it has been evolved since then, and then V2 is one of the, I would say, the latest features which we launched in 2021, but we have had a lot of features, and this is what we are going to talk about here. Now, one of the very key features what we are talking about is it scales instantly when you have hundreds of transactions, and we are talking about instantly is within seconds actually. You have a long running transactions, you have highly transactional databases, so you have a request that you want to scale or you want to scale down actually. This is where Aurora Serverless is going to come into picture, okay. And scale in fine grain increments is that is what we are saying, that you don't have to really pay for increments which you don't have to really using it. So you can start as low as 0.5 ACU, that is Aurora capacity units. When I say capacity units, it is nothing but you're talking about your provisioning, your compute, your memory, and your networking resources, okay. And when I say 0.5 ACU, it is nothing but 1 gigabyte of your memory, compute, and networking resources. So you can go as low as that actually, and you can provision that actually, okay. The third point is a full breadth of Aurora capabilities. Obviously, we have seen Vamsi has already mentioned some of those features of multi-AZ and all of that, resiliency. So you are going to really leverage all of those features while you are taking the advantage of serverless V2 also. Now, obviously, what is the business value of getting all of this is you are getting a 90% of savings, and I'm sure that most of your CTOs or CFOs is going to really look at this figure and say, yes, this is what we wanted actually, because this is the value addition the serverless V2 is coming into play actually. Yeah. Now, you might be wondering how this all happens actually. Now, this is where we are saying that the serverless V2 has a fleet of storage units, and behind the scenes it is really managing well then, okay. Now, the concept of serverless is, you might be wondering, you're saying serverless, but what is it actually? It's nothing but it's bare metal servers, we are managing it, okay. But then when there is a resource requirement, okay, you are scaling your storage units, okay, and your compute units also actually. And as you can see in the bit of animation over there, it all happens on the fly, okay. And as the demand increases, you can have your compute or storage also increasing actually, okay. And the biggest part what we are saying here is there is no impact on your applications running actually, okay. So what we are trying to do here is behind the scenes is all your transactions, we are storing it and we are trying to move seamlessly when you are doing that in the scaling manner actually. Now, obviously, you might be inquisitive that how this is all happens. I'm going to talk about in the next few slides that how are we preserving those transactions, and while we are scaling up and down, how do we ensure that we are not losing those transactions actually. Compute fleet continuously monitor and scale horizontally for the heat management, and that's where we are seeing that we have hundreds and thousands of EC2 bare metal servers, and that's where it gets provisioned on the fly or it scales down as and when the requirement is coming up and down. The background movement of all of this is preserved, and the buffer pool, what we're talking about here is all it saves the transaction level details, and it automatically grows or shrink as the demand grows actually. So the last point, what is a very key feature is we are saying that we have 15x faster scale down actually. So obviously this is a very fundamental question here is that when you try to scale up and when the demand goes down actually, the rate at which it is going down, the question is going to come that how are you ensuring that whatever live transactions you have it, you are preserving them. I don't have a risk actually, okay. So this is where we are saying that we have a very smart way of handling those things, and we are preserving all of that in the buffer pool, okay. Let's see how it goes. Now, this is the serverless, some of the use cases what we talked about, or rather we see that the value is going to come in actually. Now, the first thing is your software as a service. Now, you might be having a lot of applications where you are saying that I can use software as a service with each tenant tying to a database actually. Okay. Now, as the tenant goes on increasing into few hundreds or few thousands, you are going to have a nightmare managing them actually. Okay. Because you cannot have control on your databases actually. For example, if I have to take a backup of the database for a single database, okay, it's going to be nightmare. So what we say here is, you can have this serverless databases for each of them, and you can have better control for each of those databases, or for, in fact, it could be for each of the tenant what we are talking about. Second example or the use case could be you are having hundreds and thousands of applications kind of for an enterprise grade class. And for each of them, you are having again hundreds and thousands of databases actually. Now, this is again going to be very nightmare when you try to really expand this and manage the underlying databases, right? Now, how about that when you use the serverless for each of those databases, having a fine-grained control on that as well actually. The third is a very interesting part, and I'm sure that in a day-to-day basis, this kind of a variable workload, everybody must have really experienced. I mean, I would see a classic example would be your delivery partner, food delivery partner actually. You always see those delivery partners having a peak time in the morning, breakfast time, or in the afternoon, the lunch time, or the dinner time. The rest of the time may not be that heavy. So, or maybe there are some other applications where there is a huge gap between the peak and the average actually. So, how are you going to see that Aurora Serverless is going to really make use of these use cases and can be really good fit for such applications actually. Now, this is what I was talking about, that buffer pool resizing. Okay. So, there are two parameters. In fact, for the MySQL, it is the InnoDB parameter, and for the Postgres, it's the shared buffer parameters. Now, the way in Aurora, we provision almost 75%, okay, and for the rest, 25% is for the heap. Now, when you are trying to provision it actually, how does the scaling happens between the scale up or scale down for really handling those transactions on the line actually. Okay. The important part here is to note here is we are talking about two algorithms which really takes care is that the least frequently used and the least recently used algorithm. Using these two algorithms, we preserve those transactions and we move them across the surviving instances or the instances which are in the pool actually. Now, this is a nice little animation I would like to show in the next slide. So, this is a typical your buffer pool, okay, and your access frequency is there. Now, this is what the hot pages you can see on the right hand side actually, those are going to be red, okay. Now, there are some new requirements in terms of new data to be fetched actually. It is going to be retrieving from your storage layer, okay. And that requirement as it comes, it is going to really read from the storage layer and it is going to pull it in the buffer pool actually. Now, if you see that all of this is really making space for that, it is really going to monitor for some time and not really evict those pages as it going down actually. Okay. The moment the pages which are on the left hand side most is the ones which are very rarely used or which, as per the algorithm, okay, and those are the pages which are candidates for eviction, okay, and that's why we are going to see that. So, all of those pages which are on the most left hand side are the least recently used ones or the least frequently used one, and those are going to get evicted from your buffer pool actually. And this is where your transactions are going to preserve, okay, and you can see that your memory is going to shrink, what was earlier provision and which you are paying, okay, and that's going to shrink down. And this is where some of the savings you are going to be using it, okay. I hope this was something which you might have been really interested to see that how these transactions were really being handled, okay. Yeah, now you can see that the whole memory has been shrinked, okay. You are not paying as what you had provisioned earlier, but on the fly it is happening actually. Yes, the second thing here is the beauty of serverless V2 is you can have I would say a hybrid kind of architecture or a mixed architecture. That is, you can have a provisioned databases, okay, in a global fashion actually, and you can have your secondary clusters which could be a serverless actually. Okay. Now, what could be a classic use case of this is that you have some of your critical applications running on your provisioned ones actually, and some of your reporting applications or maybe some ad hoc reporting, you could move it to serverless, okay, and really save some of the costing actually which you are incurring unnecessarily actually, or provisioning it, okay. And these are some of the, I would say, features which the global database offers, and then what we have done is we have fusioned the global database features along with the serverless features, and that's where we are saying that this is the value addition which you get when you are having the mix of both the features of serverless and global database. So how do we really help you to migrate actually? Now there are three ways you can migrate it. First is your self-service migration. You can use some of the native tools, or you can use the DMS service, that is a data migration service, to move from your non-serverless to serverless, things like that. Or get help from a specialized database resources, okay, which are kind of a subject matter expertise who will guide you through the end-to-end process, which will take you to the live project. Okay. Third is your AWS professional services team, okay, and we do have certain partners who can help you to the end-to-end journey and help you to migrate to the serverless part. Now, obviously, this is the crux of the saying that how does the costing 90% arrive, or how do we really get that value actually. Some of these details are there, that how the serverless pricing is done. So it's pretty simple in terms of the IOPS, what is being consumed, the storage is what is being consumed. There is a small example that even for the smallest unit, what we are provisioning at 0.5 is what we are charging, and not what you was actually being provisioned in. Okay. Yes, I think, and this is one of the testimonial from one of the customer which really leveraged serverless V2, and they had a lot of savings on that. And I believe that there couldn't be a better testimony for a customer who's heavily using serverless V2. Serverless V2 summary, some of you, we can say it is cost effective, highly available, flexible. I mean, those are the features what we are trying to sum up and say, yes, go for it, serverless V2 when you have a variable kind of workloads or SaaS kind of workloads, okay, and get that cost savings benefit actually. Yes, how to get started, identify the use case that meets the needs, plan your configuration, land, and achieve the cost savings. And that's it. Thank you. Thanks. And yeah, one important announcement I have it. If you're really interested to know how these things work under the hood, saying that how the scaling happens, we have arranged a small demo. You can visit our booth and get to know some of those intricacies, what goes behind the scenes. Thank you very much.